Are you worried that you're taking the derivative of your function the wrong way? Well, let me show you that you can actually take the derivative of this function using 3 different methods. Here is our function y is equal to 3 times the quantity x squared minus x plus 1 squared. The 3 different methods that we're going to try today and execute for our derivative are the product rule, the power rule, and then also the chain rule. All 3 of these are valid ways to find the derivative for this function. One may be easier than the other, and to me, the chain rule will be the easiest for all of our types of derivatives for this function. But any one will work if you end up struggling finding it using the chain rule in general. So first, let's start with the power rule, because the power rule is the simplest. But for the power rule, we need it in the function or the form f of x is equal to some constant times x to the power, and plus all of the others that are the same kind of form. So we need it in the form of a polynomial. So for the power rule, I'm going to write this in blue. We have our function y is equal to 3 times x squared minus x plus 1 squared. In order to get into a polynomial form, we need to actually expand these quantities because right now we're not in polynomial form. So this is the same thing as saying 3 times x squared minus x plus 1 multiplied by itself, right? Easy. Now, if we expand this function out, we have 3 terms in one quantity, 3 terms in the second quantity. So we'll actually have 9 terms in our quantity when it's expanded. And let's start with this x squared term distributing out to the other 3 terms on the other side. So we'll have x to the 4th minus x cubed plus x squared. Now let's do the minus x term. We'll have minus x cubed. We'll have plus x squared. And we'll have minus x. And now we'll do the last term plus 1. So it'll be plus x squared minus x plus 1, all multiplied by 3, right? So now we can combine like terms to make this much easier for ourselves. So we'll have 3 times x to the 4th. We have 2x cubed terms, so this will become minus 2x cubed. Then we have 3x squared terms, so this will become plus 3x squared. We'll have 2x to the first term, so it will be minus 2x. And we have plus 1 at the very end. And if you add up all of these coefficients, we'll see that we have 1, 1, 2, 2, 3, which will end up with a 9. That's not always going to be the case because sometimes they negate each other. Sometimes they'll negate each other, but here they actually all add up constructively, which is cool. If we distribute this 3 here, we'll get our polynomial function. 3x to the 4th minus 6x cubed plus 9x squared minus 6x plus 3. And so if we take the derivative of y using the power rule, so dy over dx, to find dy over dx, we'll use a power rule on each individual term, multiplying by the exponent and then subtracting 1 from the exponent in a subsequent fashion. So the derivative of dy dx will be 12 because of 4 times 3 times x now cubed, right? Minus 18x squared plus 18x minus 6. And the 3 goes away because technically it's x to the 0, and anything times 0 will always be 0. So we found the derivative of y using the power rule. But again, this ended up being a lot of work using a lot of expansion and a lot of subsequent steps using algebra. So it's a way of finding it, and if this is the way that you want to find it, go right ahead. Just be careful with how you expand your terms. Next, let's use the product rule. And the product rule is going to be a little bit easier because this is where we have to have 2 functions of x multiplied by each other. And we need to have 2 functions of x multiplied by each other in this form here. And this is exactly what we have. We have these 2 quantities multiplied by each other, and so we can end up using the product rule for this derivative. So if we write it out, we actually have y is equal to 3, and this 3 can be actually on the outside of these functions of x, because this 3 will just end up distributing to our derivative in the end. So again, we have x squared minus x plus 1 multiply by itself. And so if we take the derivative of y with respect to x, what this will end up being, it will be 3 times the whole quantity, x squared minus x plus 1, multiplied by d over dx of the quantity, plus the same thing. Because these two quantities are the same, which makes it easier to know what to do. Basically, with the product rule, you're going to take the derivative of one function, multiply by the other function, not the derivative, and then add it to the same thing but reverse. Here, it doesn't matter the order because they are the same in the end. So this is the quantity now that we want to solve for. And so we actually have to use the power rule in the end here. And you'll have to use the power rule for any method, including the quotient rule, chain rule, product, in general. So if we solve for this derivative here, we'll end up getting 3 times the quantity x squared minus x plus 1, multiplied by the derivative of that quantity, which will be 2x minus 1, plus the same thing again. And then if we distribute all our terms out, we'll get 3 multiplied by the quantity, and then we'll end up squaring it in the end. But if we find them individually, we'll do the x squared term first. 2x cubed minus 2x squared plus 2x. Now we'll distribute the minus 1 term, minus x squared plus x minus 1. And then all of those will end up being double, just because it's the same thing on the other side. So I'm going to multiply that by 2, just to make it easier for ourselves. Because this is the same thing on both sides. So if we take it one step further on the bottom here, we'll distribute everything in, and we actually have to also combine our x squared terms one more time. We'll get 6 multiplied by 2x cubed minus 3x squared plus 3x minus 1. And again, we have to remember that 6 out in front. So the derivative of our function will be 12x cubed minus 18x squared plus 18x minus 6, which is the exact same thing that we found above. Very nice, very easy. Just still a little bit long when compared to when we're going to use the chain rule. The chain rule is going to be very easy in terms of how we actually find this derivative, but really chain rule just needs to be in the form of some sort of function of g of x. This looks complicated, but the most common form that you'll see is this exact form for this function of y exactly. 3 times the quantity to the power. So this looks like the product rule if x squared minus x plus 1 was actually the function of x inside of that polynomial. So using the chain rule here, to take the derivative of dy over dx, all you have to do is treat that quantity like a variable. And so we'll take the product rule of that, bring it down to 2, subtract the 1, we'll get 6 multiplied by the quantity on the inside. And then we multiply it by the derivative of that inside function. That's all you do to find the derivative of this function using the chain rule. And this is why it's the easiest, and a lot of times when you see a function of this form, the chain rule will be the easiest way to find it. But it's not the only way. Keep that in mind. So when we simplify this a little bit more, we'll factor in that 6, or distribute that 6. 6x squared minus 6x plus 6, multiplied by the derivative, and we're taking this derivative above where it's going to be 2x minus 1. And so now when we distribute out our individual terms, we'll start with our 6x squared. We'll get 12x cubed minus 6x squared. We'll do the minus 6x term now. We'll get minus 12x squared. We get plus 6x. We'll distribute out the 6 now. We'll get plus 12x minus 6. And so when we combine all our like terms, we'll get 12x cubed. Then we have minus 6 and minus 12x squared, so we'll get minus 18x squared. Then we'll get plus 18x. Then we also get a minus 6 at the end. And that is the exact same result as all three of our methods. So unless the problem itself tells you to use one specific method, like the chain rule, power, or product rule, you can actually find a lot of derivatives of a lot of functions using a lot of different methods. I hope that the takeaway from this video is that even though there's only one correct answer, there are multiple ways to find that answer, especially for derivatives. Have a great day.